Okay, good morning. Starting section 5 today. Got section 5, then 6. Section 5 will take us a couple days. Section 6 won't, because it's kind of just like this, but with one different thing. So test is coming, more on that in the Google Classroom later. All right, so write that down. You probably should pause it, write it down. Exponential and log equations, day 1. So today we do exponential equations, tomorrow log equations. Definition: exponential equation is an equation with the variable in the exponent. So just a real simple example, 2 to the x equals 32. Okay, the exponent, x, the thing we're looking for, is up in the exponent. Did I say that wrong? I said that wrong. The variable, the thing we're trying to solve for, is up in the exponent. Okay, so to solve this, when this happens, you need a log to undo the exponent. Logs and exponents are inverses. That's all that switch stuff we've done. Logs undo exponents. Okay, so I'm going to elaborate on this a little bit. We've seen this. We've seen something like, let's make it 2 to the 3x equals 32. All right, so how we solved that before is we tried to get the same base. We tried to rewrite 32 as 2 to the something, like this. So 2 to the 3x equals 2 to the 5th. And once you had this one rewritten with the same base, doesn't it make sense that these two things would have to be equal? Look, you got an equal sign in the middle. Here's the 2, and it equals this 2. So then this exponent must equal this exponent. So then we set it up like this, and then we would solve. Okay? Well, that's not what we're going to have today. We're not going to have the same exact bases. Okay? Today, bases are different. And I mean real different, like there is no way you're going to be able to relate them. Let's get started with our examples. Okay, so 3 to the x equals, wouldn't it be nice if I wrote a 9? But I'm not going to. I'm going to write a 4. You cannot change this, either of these, to fit the other one. So here's what we do. The thing we're trying to solve for is up in the exponent. So take a log. Take a log on this side and a log on this side. It's just a math operation, like if you'd minus 7 from here, minus 7 from here. Well, that last section with all those properties of logs tells us that when you've got the exponent up here, do you remember where it goes, what it does? Yeah, you bring it down. So that side is now x times log 3, which is just some number on your calculator, which I'm going to need. You're going to need. Okay, and then on this side, log 4. It's just some number. Okay, so x is being multiplied by whatever that number is. So let's divide both sides by log 3. Okay, now, do not think of this as, well, I'm going to cancel the G and cancel the G. No, it's like in geometry when you'd have like inverse tangent over here. An inverse, you don't cancel those individual letters. This is a whole thing, a log, a math operation. This cancels with this. So x equals log 4 divided by log 3. Get your calculator and figure out what those decimal numbers are. All right, so there's a couple ways you can do this. Turn it on. You can figure out individually what each of these things are. Log 4, so the log button is next. It's in this column right down here by the 7. Log 4. And you might want to close the parentheses and then just hit enter and you get 0.6021. That last digit, I rounded it, but if you would leave it as the 0 that I see on my screen here, it's not going to make a much difference because this is the tenths, hundredths, 10,000ths, that's so tiny. Divided by, now let's figure out what log 3 is. Log 3 is 0.4771, and then just do this division. So I'm going to clear it and do 0.6021 divided by 0.4771, and I get, I'll just put it here, x equals 1.262. That's it. Okay, now, some people do not want to do these individual calculations, and let's just see it. What if I plug this whole entire thing in? You're probably going to get this, but let's check. So you need to make sure you are using parentheses around that entire thing. Log 4, close it, now divided by. Open a new one, log 3, close it, hit enter. Oh, well, will you look at that? That gives me 1.2618. So look, the 1/8 would round, so I get real close. Okay, so we're allowed to be a tiny bit off. Probably better to give more decimal places. You get a more exact answer. Okay, so let's try something a little more exciting. This next example, whoops. Six to the, okay, that was just plain old x. Let's do to the 2x. And that equals 21. Would have been nice if it was like a 36, but it's not. So here's what we have to do. The thing I'm trying to solve for is stuck up in the exponent. So take a log to bring it down. Log on this side, log on this side. So your next step, 2x times log 6 equals log 21. Okay, so on this side, you know you have to divide by this. That's like that last example. But you're going to divide by this 2 also. This entire side is going to divide by 2 times log 6, whatever number that is. So divide this side by 2 times log 6. X equals, okay, so log 21 divided by 2 times log 6. So I strongly recommend you use parentheses around the top and around the entire bottom. This should turn out to be 0.8496. Okay, so you just got to practice punching in the correct order, the parentheses. Let's try a couple more. Hold on. Okay, let's do another one. Oh, and the directions are all solve for x. Okay, so 7 to the 3x equals 20. The x is stuck up in the exponent, so take a log to bring it down on both sides. 3x times log 7, which is just some decimal number, equals log 20, which is just some decimal number. So x, whoops, that's not what I want to do yet. Forgot my dividing. Divide both sides by 3 log 7. 3 times log 7. And x is finally all alone. So this right here is what you type into your calculator. Parentheses around the top, parentheses around the bottom, or else your calculator might mess stuff up. This should turn out to be approximately 0.5132. Let's go with 4 decimal places. Put 4 decimal places. Okay? All right, so now here's how they get even more exciting. I can put it right here. 3 to the, now this exponent is a binomial, x plus 4, and that equals 101. Well, you do it the exact same way because the variable is up in the exponent, so take a log over here, take a log over here. That will bring down this exponent. Now, I'm putting parentheses around it. You should too. Over here, it's not such a big deal because everything's all multiplied. This is not. You know how picky terms are, so use parentheses. Times log 3 equals log 101. Okay, let's divide both sides by log 3 first. I do not want to combine too many steps since I got addition in here. It's not as simple as these past 2 examples where it's all multiplied. Okay, so yeah, cancel, cancel. So x plus 4 is over there. And let's figure out what decimal number this is. Punch it in your calculator, and you should get 4.2009. Now, how do you solve for x? It's an Algebra 1 question now. You solve for x by subtracting 4 from both sides. When you subtract decimals, remember how you got to line them up? I'm just going to use the calculator anyways. 0.2009. Okay, now, every one of these equations, these examples that we've done, have been common logs. Let's review that for a minute. Common log. Do you remember what that is? Huh? Do you? Do you? That is when the base is 10. And it's so common that you don't even have to write it. Okay? So like over here, when it's not written, we're all assuming it's base 10. Well, base 10 is what our calculators are built on. So you definitely want to use common logs. Okay? Otherwise, how are you going to figure these out without the calculator? Okay, so what if it's not base 10? What if it's not a common log? Well, we got a formula for that. Really, really, really simple. It is called the change of base formula. And here's how it goes. Let's say you have log base b, just representing some random number, of m. And it's not a 10. Well, here's what you do. Turn these two things into common logs. Log m divided by log b. Look where all the letters went. The base comes down to the denominator, and it's not a base anymore. It's like log base 10 of b. Because now I can do calculator for this, calculator for this. Let me show you with some numbers. Okay. So this won't be a solve question. This will be an evaluate. Evaluate means tell me what the actual answer is. Work it out a little bit. Tell me what the answer is. Log base 3 of 15. See, your calculator won't do that. I take that back. There is, if you got the big fancy kind, there is a button called the change of base. It'll do that for you. I think it's somewhere under mode or math. I'm going to make you work the thing out though. I'm going to need to see this work. All right, so here's what you do. Your first step. Turn this into a division problem. Common log, 15 on top, log base 10 of 3 on bottom. Get the calculator and do this division problem. See, now you can put the decimal answer, which is 2.465. And I don't know what the other decimal is. But anyways, there we go. We got 4 places. Okay? So when you're solving, you take a log to bring it down. Evaluate using the change of base formula. This is all I need to see. Okay? All right, let's see if we got another example here. One more. I'm going to erase in the middle here. One more solving. Solve 5 to the, not 2, x minus 2 equals 20. Okay, if I write 5, it's 25. You can do this the old way, where if it's 25, then you'd rewrite it as 5 squared, and x minus 2 equals the 2. It's not a 5 though. It's a 7. Yeah, it's a 7. Okay, so take a log to bring it down. That's a log. There, log. Take a log. Parentheses around a binomial. Take a log is a math operation. You do it on, if you do it on the left, do it on the right. So let's divide both sides by log 5. X minus 2 is all you have left over here. And this is just decimal stuff. Get your calculator. Log 27 divided by, I'm going to open a new set of parentheses. Log 5, close it, hit enter. 2.0478. Add 2, x equals 4.0478. Okay, try some of those, because tomorrow we do log equations. It's like we go backwards of this stuff. Okay, so see ya.